So we're going to start looking at data and data analysis. And data analysis is getting more and more important because as we have more and more data available to us, we have to make sure that we're analyzing this and being able to get the appropriate information and be able to interpret the information. So we're going to collect and organize information so that we can see how events occur and how to determine some probabilities. So we're going to work with some of the see how data can help us with chance and probability. And secondly, we also want to see patterns in data so that we can make some informed decisions about some data. So there's different ways that data can be shown. We can look at frequency trends, okay, and these bar graphs, or what we call histograms, are a way to show relationships. So in this case here, this is on the y-axis. This represents the number of people. On the x-axis represents the heights of people. So we have this bar representing people of heights of 160 centimeters, 170, 180, 190, 200. So we have a few here, lots here. So what can we interpret about this data? Okay, so what we can interpret is basically that there are more people in the middle, okay, or more people of what we would call kind of maybe average height. So there's most people are around 180 centimeters, and there's few people that are short or tall, that are 160 centimeters and 200 centimeters tall. Okay, so those are the shorter and taller people. So, and this is something we would kind of expect. This is what we call a normal distribution. Okay, so this one here, we have a chart here. The y-axis, the height of this chart represents the number of people. Okay, the x-axis represents the ethnicities of these different people. So this is in 1961. So the ethnic origin. Okay, so we have the table here, which is now the same table as what we see from this chart. Okay, so this is a tabular form of this information, and this represents the bar graph or histogram form of this information. So we have here, like, the higher the graph, the more people there are. So we get a very quick relative reference of how many people are from these different backgrounds. So if we look at it, we can see that right away, just visually, we can see that Japanese origin are very small, whereas Italian and Ukrainian are quite large. Okay, so if we were to just kind of randomly select a person from this population, what is the least likely origin that we should get? Well, the least likely is likely going to be due to the fewest number of people. Okay, so in this case, it's going to be, we're probably going to least likely select a person of Japanese origin. Okay, this is what we mean about the data being able to inform us about probabilities as well. Now, it is important to note that there is a difference in these two bar graphs in that this one here is what is a continuous x-axis, so meaning that we go from small to large. This one here, there's no real organization of the x-axis. So in terms of what we're seeing in terms of distribution, there's not really any sort of trend. Whereas this one here, we see the central trend here. Okay, so that's important to note. Another type of pattern is a scatter plot, okay, or a dot graph. And we can see that we are connecting or relating shoe size here to height. Along the x-axis is height, and along the y-axis is shoe size. So as we go to the right, we get taller people. As we go up, we get bigger shoe sizes. So we can see that there is this relationship that is going kind of in this direction. Okay, so this is what we call a positive trend. Okay, there tends to be a positive trend in this relationship. So in this positive trend, what can we interpret? Well, we can see that as we have taller people tend to have bigger shoe sizes. So we're just going to write that down. Taller people have larger shoe sizes. Does that mean that tall people have bigger shoe sizes than shorter people? Not necessarily, because there are, if you maybe take a look here, this person is taller, yet they have, sorry, where would it be a good example here? Here, this person is taller, yeah, this one is taller, yet has a, well, let's see, compared to, so this is a tall person who has a little bit shorter, smaller shoe size, or about the same shoe size as this person here. So this one is taller, this one's shorter, this person has a larger shoe size. So that relationship is not always true, but we can say that it is generally true. So here, this data shows the number of infant deaths in Canada, or infant mortality rate, and it looks like there is a negative trend here. Okay, so there's a negative trend. So it's trending downwards. It's maybe not necessarily a straight line. It looks like it's kind of curving, but this is a negative trend. Okay, and we can see that, so there's a negative trend with this data. Okay. And we can see as the years go along, we're having less and less infant mortality. So we have less infant mortality as time goes on. Now this is something we should probably expect as we have better and better medical systems. Okay. Okay, so as we increase time, we're just getting more and more science, we're getting better medical systems, so we're going to end up with less infant mortalities. Okay. So here we can do our own scatter plot. So if we plot these points on this data, we can plot along the x-axis years and along the y-axis is distance. Okay, so we can plot the shot put records and see if there's some sort of trend. This is going to be what we're looking for. So in 1984, the shot put record was 22.09. So let's say it's somewhere around here. Okay, so I want you guys to do this on your graphs as well. In 1986, it's 22.64. So 22.64, maybe somewhere around here. 1987 is 22.91. So somewhere maybe just right about there. Okay, in 1988. We have 22.06, so maybe somewhere around there. And in 1990, we're at 23.12, so maybe right about there. Okay, so we can see that there, again, is this positive trend, okay, in the data. So there's a positive trend in the data that is, we can say that the world record is increasing, okay. The world record is increasing as time goes on. Okay, so, and we kind of should expect this because, you know, the better science, better nutrition, but it looks like it seems to be dropping off a little bit here. In fact, this one here seems to be a little bit off. You would think based on the linear trend anyways, that we should maybe have a higher, a bigger world record here, or longer world record. You know, and there could be some explanations to this, and it's interesting to try to interpret and make some justification for this data. You know, maybe since 1988, you know, there's a big drug scandal in the Olympics in 1988. Maybe because of that, people are not doing performance enhancing drugs, and we can see that maybe that's the reason why these world records were tailing off at that point. Okay, so we can start giving some justifications, some hypotheses. Now, obviously, we have to test these things, but if we were to try to justify that, we do have the data does seem to lean towards that sort of justification. Okay, so that is one way, again, we can use data. We can interpret these results and see and make some conclusions or try to justify our conclusions based on these trends. Okay, so let's do this one here. This is, I want you to do this scatter plot, and I'm going to pause the video so that you can do this on your own, and then you can see how I've done it.